This is the video for 5.2, verifying trig identities. I want you to work only on one side of the equal sign. I know there are some problems in the book, and if you look at some of the examples that have you do them on both sides, but because of how you do things in calculus, needing to simplify to one thing and verifying things, I'm only going to have you work on one side. So you're sort of doing a proof. So you need to simply prove that one side of your expression simplifies to the other. And do not move anything from one side to the other. So I don't want you moving things around. You pick one side to work on and you stay on that side. You don't move anything around. Okay. So these are similar to what you had in 5.1 in that you have an equation, but now you have the answer. So you actually know where you're going. So you're going to try to make one side match the other. I would go for the side that's more complicated. If it's got fractions in it, go with that side. If it's got tangents and cotangents, go with that side. Again, your goal is to get everything in terms of sines and cosines if you can. However, in this particular case, my cotangent I'm going to leave alone. Oops, let me change the width of my pen. My cotangent I'm going to leave alone because secant squared minus 1 is tangent squared. So if I can get this to tangent squared, I'm just going to change cotangent squared to 1 over tangent squared. So just work on the left side, leave the right side alone. And then that's just going to cancel, and you're going to end up with 1. And that you've basically proved that cotangent squared, secant squared minus 1 is equal to 1. Number 2. Cosine squared minus sine squared equals 2 cosine squared minus 1. So you have two options. You can work on the left or you can work on the right. Since there's two different trig functions here, and there's only one here, I would go with this side. So since I want to get to only cosines, I need to basically get rid of sine. So I'm going to think of what I can plug into sine squared to do that. So I'm going to leave my cosine squared alone. And sine squared, I'm going to replace with 1 minus cosine squared from your identities. That gives me cosine squared x. And remember, just like your identity, or your 5.1, you need to show all of your work. That's minus 1 plus cosine squared. Cosine squared plus cosine squared is 2 cosine squared x minus 1, which is what I wanted to make it match to. It equals 2 cosine squared x minus 1. Number 3 looks really, really hard. So we're going to take this a little bit at a time. So I'm going to multiply through my secant squared times each of these. So this is going to give me secant to the 7th x tangent. Multiply secant to the 4th times that. So this is minus secant to the 5th tangent. So for each one of these terms, there's 7 secants here, 5 here. I can take out 5. And I can take out 1 tangent. So I'm going to take out a secant to the 5th and a tangent. I'm going to factor it out. What's left is secant squared minus 1. Secant squared minus 1, that's one of your identities, is tangent squared. And then your secant squared, or sorry, your secant to the 5th is now multiplied by tangent cubed, which equals your secant to the 5th tangent cubed. So your goal is just to make them match. Okay. We have cosecant pi over 2 minus x divided by secant of pi over 2 minus x equals tangent. So cosecant of pi over 2 minus x is equal to secant of x. Secant of pi over 2 minus x is equal to cosecant of x. Secant is equal to 1 over cosine. Cosecant is 1 over sine. So if I copy dot flip this, oops, that's going to give me sine over cosine which is tangent. And that's what I wanted it to equal. 5 looks a little bit different because it's got x's and y's in it. So you're going to have to keep track of your x's and y's. I'm going to work on the right-hand side. So my cotangent is equal to 1 over tangent of x plus 1 over tangent of y over 1 over tangent x tangent y minus 1. Then, let me just keep changing colors so you can see where I'm going. Then I'm going to get common denominators, which on the top is going to give me tangent y plus tangent x over my common denominator of tangent x tangent y. On the bottom, I need to get that, have a common denominator. So this is going to be 1 minus tangent x tangent y over tangent x tangent y. If I copy dot flip it, we're going to end up having that will go away. Tangent y plus tangent x over 1 minus tangent x tangent y. And tangent y plus tangent x is the same thing as tangent x plus tangent y. And then 1 minus tangent x tangent y. So as long as you keep track of all of your, and it equals tangent x plus tangent y over 1 minus tangent x tangent y. So I'm going to keep the left side the same. Number 6 says cosine of theta plus 1 over tangent squared equals cosine over secant theta minus 1. So let's start with the left-hand side. Tangent squared, I can change to, let me change colors. I can change this to, so cosine theta plus 1. I can change this to secant squared theta minus 1, which doesn't exactly equal what you have there. So for the time being, I want to be able to get to a secant theta minus 1 instead of a secant squared. I'm going to change cosine to 1 over secant because if I can get a secant theta plus 1 on top, it will cancel with the factoring on the bottom one. So this is going to give me 1 plus secant theta over secant theta. And then secant squared theta minus 1 factors to secant theta, minus 1, secant theta plus 1. This is still the same. So then that's 1 plus secant theta over secant. If I copy dot flip it, times 1 over secant theta minus 1 secant theta plus 1. These will cancel, and I'm left with 1 over secant theta times 1 over secant theta minus 1. 1 over secant theta is cosine, so you end up with cosine theta over secant theta minus 1, which is what you were trying to match. So they work.